Here to talk to you today about the this keyword in JavaScript. My name is Buwa, and I am a developer, a software engineer at Sainsbury's Argos. All right, so I've only been at Argos for about 6 months, and I was talking to an acquaintance a few months ago, and I said I now work at Argos. And she said, "Is that your second job?" I was like, "It's my first job, my 9 to 5. She goes, "So why would you leave tech for Argos?" And I'm like, you know, Argos has a website, they have mobile apps and things like that. She goes, "Oh." So I'll just tell you a little bit about Argos Tech. Argos is the third biggest e-commerce website in the UK. I can tell you about the other two, but we'll keep the focus on Argos, yeah? It's the biggest British-owned e-commerce website as well. So the other two are in British, we don't care about them. Argos gets about 1.8 million visits daily on average, and 120,000 orders are processed daily on the website. So if it's not obvious yet, I'm saying all of these things because we're hiring. And we've got offices in Victoria, Holborn, Milton Keynes, and Manchester. And I am a diversity champion at Argos, and I'd like to see more minority and ethnic people in the tech sector. Argos also has a vibrant LGBTQI community, which is already it's very active across the other sectors except the tech sector. So tell your friends, tell anybody you know. It's a very inclusive community. It's a very nice place to work. So again, still on Argos, this is our tech stack, and I really enjoyed your talk because sometimes as JavaScript developers, we forget that there's something called HTML or even CSS. So yeah, that's why it's at the very start. That's the base technology we use. It's HTML, CSS, and then the host of the others. So we've got iOS teams, Android teams, DevOps, whatever it is you do in the tech field, would like to hear from you. And I've got some cards I could hand out after the talk if anybody's interested. Okay, so back to the focus of this talk. We'll be talking about the this keyword in JavaScript. When I started delving deeper into JavaScript, it was a source of confusion for me. All right, and that's because, first of all, so this is a definition I made up. So it's a dynamic JavaScript keyword, which is automatically defined within the scope of every function and whose value depends on the context it is being used. It's not the official definition. I couldn't find it. But I think part of the confusion comes from the last part of this sentence, right? The value depends on the context it is being used. If it is this confusing, you then wonder, why do we even bother with it, right? And it's a very simple answer. Using this keyword correctly, it gives you very elegant flexibility. So if you use it in the right way, then your code can perform a cartwheel as elegant as this lady. All right? That's the only reason why you use it. I'll try to demonstrate. This is a simple piece of code, contrived. We have 2 objects and we have 2 functions. Now both functions take a details parameter or a details argument, and when I invoke the function twice at the bottom of the screen, I am explicitly passing those objects into it. Now this is the same piece of code, but this time around I'm referencing the this context to pass those objects in. And if you'd notice the difference between both of them, here where I define the functions, I have actually specified the arguments it receives. In the other one, there are no arguments. So basically, being able to use the this keyword sort of gives you that ability to write cleaner APIs, and it makes your code easy to reuse. So if I could ask you guys, I know we've just played a game, but I'll ask you to please have a look at this code snippet. It's really simple, right? I have a print char function. All it does is log whatever character is passed into it. And I want to know how many times I've called this function. So I have a count, a this.count, which is incremented each time the function is called. Now we know functions are objects in JavaScript, so I have set the count property of that object to 0. And now I am looping through this array of alphabets and calling that function at some point. Can anybody please tell me, when I do console.log, what the expected answer will be? 0, I had 0 there. 5. Say, undefined. Okay, undefined.
1.
1. Any more guesses?
0.
0, undefined 1.
0.
4. Okay. Well, the correct answer is 0. And when I first started with JavaScript, this was one of the confusions for me. As it turns out, the this keyword in JavaScript never refers to the function itself. Right? That's one of the major confusions with the this keyword. Right? Now, you could also try to do things like this, where you try to go across the scopes of functions. And as you can see there, computer says no, it doesn't work. Right? And the reason for that is that this does not refer to a function's lexical scope. So we've eliminated two confusions. It doesn't refer to the function itself. It doesn't refer to the lexical scope. So what does this actually refer to? Well, it's determined at the function invoked. So at the point where the function is invoked, this is determined at that point, and it refers to whatever object the function is invoked on. So to sort of illustrate that, you have to first of all look for the call site, right? That's where the function is invoked. So here I have three functions, bars, bar, and foo. Bars is in the global, so the call site for bars is in the global object, this is where. And bar is in bars, foo is in bar, right? So that's the call site. Now, that's one side of it. How do we then determine what object it actually refers to? As it turns out, there are rules for doing this, right? So we'll talk about some of the rules now, well, all the rules, and we'll start with the default binding rule. So I'll go back to front. This is the rule that applies when no other rule applies, right? And when there's no other rule, when no other rule applies, the this keyword will default to the global object, right? So in this case, when I invoke the default binding function, it simply references the ref object and the global object, right? And so you have global. There is a caveat though. So if I'm in strict mode, then this keyword will default to undefined. And that's because JavaScript creators thought that if you're referring to the this keyword, referring to the global object with your this keyword, then it's probably an error in your API design and you should go back to fix it. So if you're in strict mode, you get undefined. The next rule we'll look at will be the implicit binding rule. So here, I have a function, and I have passed a reference to that function into the object. Now, when I call that function on the object, this keyword is implicitly bound to that object. So I get implicit binding when I invoke that function, right? And it also doesn't matter if I have chained my objects. It will always be the last object that was the last object. It will always be the object the function is bound to. So the last one before the function invocation. So here I have a transit object which references a ref object and still invokes the function. I still get implicit binding. I've got another question. So knowing what we know so far, when I do get location and I pass in traveler at current location, what do you think the answer, what do you think will be output on the console? worldwide. Current location. Okay, that's interesting. How did you get that? Well, the answer is worldwide, right? And it's simple. At the point we have invoked, so I don't know, can you see you can't see my mouse. So this is the point of invocation. So that's the hint, that's the call site. And at that point, only the default binding rule applies. So it takes location from the global object, right? Now we have the next rule, explicit binding. So you've seen this previously at the beginning of the talk where I've explicitly said greeting.call and I've passed these objects to it. So at this point, it knows explicitly I've said, this is the object I need you to reference. So it takes the details from the explicitly bound object. Now, some JavaScript libraries, so if you try to explicitly bind some JavaScript libraries and let's say you're working with your import modules and you're doing stuff with this keyword in it, it could mess up what you expected it to do. So as JavaScript developers, we came up with a solution. It's called hard binding, right? So we have a function, and within that function, we'll hard bind this keyword to a certain object. And so no matter what any library does or anything, whenever we call that function, we are very certain that we'll get our object, this keyword bound to the object we want. As it turns out, this was a very popular technique. So in ES5, JavaScript, the JavaScript working group, they came up with something called function.prototype.bind. So all it does, so this is the same as this, but this time around we're using the inbuilt bind function that comes with JavaScript, right? So you remember at the beginning I spoke about the flexibility that comes from using this keyword. However, we've just hard bound it, and now we've taken away that flexibility. Would that be right or would that be wrong? There really is no right or wrong answer. It really depends on what you're trying to do and how you're trying to, it depends on what you're trying to achieve really. And what you're trying to achieve will inform whatever method of binding you choose to go for. So there is one more method of binding, and it's the new keyword. Coming from other object-oriented languages, when you use the new keyword, you most likely getting a new instance of a class or something. But it doesn't work like that in JavaScript. And for our purposes, we'll just say JavaScript returns, when you use the new keyword for binding, you get an object with this keyword bound to that object. So in this case, when I use the new keyword on the demo new binding, immediately I get function scope as my return value. The only exception to that will be if the new function I'm binding, if it has an explicit return object. So where it has an explicit return object, then my this is bound to that return object and not the same way it was here where it was just bound to the object. It's bound to the explicit return object within that function. So how do you determine the order of precedence? I've got this long text here, but in summary, it's really the new keyword that has the utmost priority, and then you have the explicit and hard binding, which have the same level of priority. You've got implicit binding, and then last but not least, you've got default binding. Right. So there are a few exceptions to this rule, but for our purposes, I'll just talk about the arrow functions. So in my definition earlier, if you had noticed, I had the every function in asterisk, and that's because the fat arrow functions introduced in ES6 do not come with their own this binding. So whenever you use a fat arrow function, it uses a this binding that's attached to its enclosing scope. So in this case, what I tried to do, if I go a few slides back where computer says wouldn't work, so here, here, If I were using fat arrow functions here, I'd be able to get away with some of the things. Obviously, I'd still get undefined because won't work as not in the global scope, but it wouldn't. So that's the only time where this keyword actually uses the lexical scope because it's a fat arrow function, right? Further reading, you can read the You Don't Know JS. It's by Kyle Simpson. His name's been mentioned here. The books are free online, and that's a link to it. And now I would try to answer any questions.
Hello. Could you give an example of when, or in some way highlight when it would be more appropriate in a real life situation to use, how can I word this? To use fat arrow function and scope it that way as opposed to the other.
Yeah, that's what I've just said. So like I was, if you, I don't know, if you've seen, I don't know if you've seen any
I've seen it in React, yeah.
Yeah, so
like in terms of like, so for instance, I think if a function is defined as, is assigned to an object property, that's one instance when it's more appropriate to use one over the other, but it would just be good to have some clarification.
So it depends. Do you want that function to have its internal this binding, right? And if it doesn't need one, right, then it's easier to use an arrow function. If it needs one, then obviously it's easier to go. So say for instance, I wanted to create a function.
I'm struggling with learning this myself. I'm a beginner, so that's why I'm.
Okay, so let me give an example, maybe something a bit more specific. If I was writing, do you know what currying is? No. So currying is the ability to. So basically, I have a function, and how do I explain this easily? I return a function, so it's a function that returns a function that's called later, right? So if I were doing something like that, then more likely I'd want to go for fat arrow functions. The reason is that it's then easier to use in the future because I'm not worried about this context getting, it doesn't have its own this context, so it will use whatever context I pass to it when I query it, right? When I eventually call it, it will use whatever this context I pass to it. But if I've written it in the traditional way, then I have to think a bit, when I'm calling that function to say, does it have a this, so it's a bit, it's what's the word? It's loosely coupled, if that's the right word to use for it.
Currying, yeah.
Yes, currying. Right. So that's one example where I'd fall to fat arrow functions as against regular functions. Thank you for having me.